Lesson 115C, the last part of lesson 115, is on interest and the compounding of interest. Historically, interest used to compound annually. Today, however, most interest is compounded exponentially. So I'm going to give you two formulas. One is for if interest is compounded annually, so it's annual compounding of interest. And the other one is exponential compounding. Exponential compounding of interest is very similar to the bacteria one, exponentially increasing that I taught you yesterday in class. All right, so if it's annual compounding, you're going to look at the amount over time equals the principal, that's the amount you deposited, times 1 plus the rate, that raised to the amount of time. All right, so if I go in and I deposit $100 into the bank, and they tell me that I'm going to earn interest at a rate, so I'm going to deposit $100 at 8%, and I want to know what the value of that is after 3 years. And they tell me that my interest is going to be compounded annually. So the amount after 3 years is going to be $100, that's the principal, times 1 plus the rate. You convert your rate to a decimal place. All right, raised to 3 years. All right, so hand me my calculator, please, Thomas. All right, so that the amount after 3 years is going to be $100 times 1.08 cubed. Thank you, Thomas. TQ. So if I cube 1.08, that gives me rounded 1.259. So the amount after 3 years is $100, $125.97. All right. If I looked at it after 1 year, it'd be 100 times 1.08, and that would be raised to the first exponent, right? And that would be $108. All right. Now, exponential compounding. Let's take this same scenario. All right. The formula, and we'll use it for the formula for exponential. The formula for exponential is the amount over time is the principal, and just as we did with bacteria, we're going to have E. And it's going to be raised to the 0.08, that's our rate times time. So it's E raised to the rate times time, and we have 3 years. All right? So my amount over time is going to equal my $100 that I deposit times E, and 0.08 times 3, 0.08 times 3 is, I should have known this, 0.24. So multiplying that out, and you'll see that exponential compounding is always better. All right, so it's 100 times E to the 0.24, which is the amount over 3 years is $127.12. What exponential compounding says is every day as I earn interest, then my principal increases and I earn interest on my interest, all right? Now, let's look at exponential compounding and practice problem 115.4. All right, so I'm going to rewrite my formula for exponential compounding. It's the amount over time equals the principal times E to the rate times the time. All right, so in 115.4, it says, Roger deposited $5,000. That's the amount of his original principal. That's what he deposits to earn money on, all right, in an interest-bearing account that paid 7.5%. All right, 7.5%. 0.5% converts to 0.075 as a decimal. So it's E, and my rate is 0.075, all right? Interest compounding continuously. How much money did he have in 10 years? So the amount after 10 years, and our time is 10 years, all right? 10. So our amount after 10 years is 5,000 times E, and 0.07 times 10 is just 0.75. Just move the decimal place one. E to the 0.75. So the amount after 10 years, I'm going to multiply 5,000 times E. How do I get E? Do you remember? It's shift LN, because E is your natural log. All right? So it's 5,000 times E to the 0.75. And over just after 10 years, I'm going to have $10,585. All right, so what is your lesson? Start investing early, because just $5,000 at 7.5%, our rates are not that high now. They're half that. At half of that, you get, after 10 years, $10,000. All right, let's look at practice problem A. I want to work practice problem A for this lesson. All right, so this is practice A. Practice problem A. All right, it says solve 27 equals 10 to the x plus 5. All right, 10 is my base, right? I want to be able to have an exponent to an exponent. So I have to put 27 as 10 to an exponent. So what is it? The log, my base is 10. I want my answer to be 27, that's my anti-logarithm, right? Equals, I don't know what my exponent is, all right? So I find the log of 10 to be, the log of 27 to be 1.43. So x is 1.43. So this is 10 to the 1.43. I've now converted 27 to 10 to an exponent equals 10 to x plus 5. Now how do I solve? I put my exponents equal to my exponent. So 1.43 equals x plus 5. What do? I subtract my 5 on both sides. X equals 1.43 minus 5. 1.43 minus 5 is negative 3.57. That's what x equals. All right. Work through this lesson and come with questions on, actually you have a test on Tuesday. So email me questions. Thank you.